Find the derivative of f of x equals the square root of x times the cubed root of x. Then evaluate f prime of 64. So f of x is made up of two functions multiplying each other. Instead of using the product rule, we can physically multiply these functions. We'll have to first write these as fractional exponents. They're roots, which means they can be written as a fractional exponent. The first one is the square root of x to the first power. X to the first power, and then the square root is a 2 in the denominator of its exponent. The next one is x to the first power under a cubed root. X to the first power and then the root of cubed root. We can combine these together by multiplication. That requires us to add those exponents, so 1/2 plus 1/3, which means we need a common denominator between them. I'm going to multiply the 1/2 by 3 over 3 and the 1/3 by 2 over 2. So this will be x to the 3 over 6 plus 2 over 6, which is going to give us x to the 5 over 6. So that original expression is all just equivalent to x to the 5 over 6. Our next step is to take the derivative. F prime of x equals, and it's a power rule, 5/6 times x raised to the 5/6 and then minus 1. Instead of calling it minus 1, I'll call it minus 6 over 6 so that we can combine those fractions together. And we're going to have 5/6 x to the 5 minus 6, which is negative 1 over 6. Since I'm resulting in a negative exponent, I'm going to move it to the denominator. It'll go down there with the 6 as a positive 1/6. Now that can also be written as the 6th root of x. The next thing to do is to evaluate f prime of 64, which means to plug 64 into all of the x's. And that's 5 over 6 times the 6th root of 64. Well, 64 is a bunch of 2's multiplying each other. 2 times 2 is 4, times a 2 is 8, times a 2 is 16, times a 2 is a 32, and then times one more 2 is a 64. So 64 is 2 to the 6th power. The 6th root of 64 will be a 2. Five divided by 6 times 2, which will give us 5 over 12.